In this mini lecture, we're going to cover independent and paired t-tests, additional inferential statistics that you might use to analyze the data in your project. Again, these statistics are very common, and an understanding of what they are and what they do will help you maybe understand the results section of some of the articles that you've been reading. So the first thing we'll talk about is the independent t-test. The independent t-test is basically used to test the difference between the means of two groups. So you have group A and group B, maybe males and females, and you want to see, do they differ in some important way on some outcome variable, maybe empathy. So you administer the test to both in males and females, you score it, and you want to see, do the means of one group differ from the other. The t-test actually has an interesting history as it relates to beer. So over here you can see this lovely pint of Guinness, and you might say, what do statistics have to do with Guinness? And the answer is, well, one, that statistics and learning of statistics might go very well with a Guinness in hand. But the other is that beer was actually one of the underpinnings of the development of the independent t-test. So William Sealy Gossett actually worked for Guinness, the brewery in Dublin. And much like today, when you work for some companies and you're doing particular things, they tend to own the rights, or at least can prevent you from sharing things that they consider trade secrets. So basically, William Sealy Gossett was a chemist at Guinness, and he was trying to brew a better beer. And as part of doing that, he came up with the t-test, which was really what he envisioned as a cheap way to monitor the quality of stout. So, using chemical analysis to decide whether the quality of the stout was up to snuff or not for Guinness. Guinness, of course, did not allow him to publish the results, as they would consider it trade secret. So if you actually look at the name of t-test, it's published under the moniker A Student's t-test. And that is because he had to use a pseudonym to be able to publish it and not get in trouble with the man. So the t-test has an interesting history. How does it actually work? Well, basically, you are comparing the mean of two groups. Now, one of the factors that's important in the formula is the degrees of freedom, or basically how many observations that you have minus 2. So the degrees of freedom for a t-test are however many observations you have and minus 2 for the degrees of freedom. So if you had 100 observations, your degrees of freedom would be 98. What does that allow you to do? Well, basically, the critical t-value is the value that you sort of get once you crank through the formula of comparing the two means. But then the actual decision as to whether something is statistically significant or not depends on the degrees of freedom, depends on how many observations you have. So the critical t at which something will be significant for 100 participants is different than the critical t for which it will be significant at 1,000 participants. And as you might guess, the critical t value is smaller at larger numbers of participants. It takes less for it to be significant than with fewer participants. The critical t value will end up sort of being bigger, and you'll have to sort of meet a higher threshold before you would declare something significant. So the number of participants is essential in deciding whether something is significant or not. The degrees of freedom used to be a little bit more important in the sense of you would need to have known them to be able to look up the critical t-value at which something would be significant in a big old table at the back of a statistics book. We don't really do this anymore. SPSS basically will calculate that for us. But there are some assumptions for a t-test, and one is that it assumes a normal distribution, that your distribution for the most part sort of follows the bell-shaped curve, and that group numbers are not too small. So the observations you have in each group is not necessarily too small. And a t-test, of course, measures the means between two groups. So if you have more than two groups, the t-test is not an appropriate statistic to test whatever it is you're looking for. So it has to be male-female, it can be Republican, Democrat, etc., etc. It cannot be something like freshman, sophomore, junior, senior. That's four groups, four levels to the independent variable, and so the t-test is not appropriate. Of course, when you look at the scaling of your data, the dependent variable, your outcome variable, has to be something continuous, and your independent variable has to be something categorical. So if you were interested in the amount of beer consumption, number of pints of beer, that is something continuous, and then you look at something categorical like gender, male, female, if you were interested in seeing whether men or women tend to drink more on an average night. So to give you a basic design that we've sort of looked at before, we talked about Kelly's class experiment, where one half of the class was randomly given a flyer that described the visitor that was coming next class as warm and friendly and a really great lecturer and expert in their field. And the other half of the class was given the exact same flyer with almost the exact same description, except that half the class was given the sort of cold description. The person was an expert in their field, and but they tended to be cold and aloof and maybe not perceived as friendly. And we said, the results were that people tended to rate the person with the warm persona as having given a better talk and having enjoyed it more. With an independent groups design, participants have to be randomly assigned into conditions. So in this experiment, students were given either the warm flyer or the cold flyer completely randomly by just every other person was handed a particular flyer in a row. And the participants are only in one group. You can either be in the warm condition or the cold condition. You cannot be in both. So that is the independent groups design. If you're looking to test the difference between two means, between a warm condition and a cold condition to see whether ratings of the class visitors' presentation were better or worse, the independent groups design is for you. The other t-test is a paired t-test. The paired t-test for dependent samples is basically used to test the difference between means on a variable that you're interested in when you collect data on that variable at different times. In this case, for the paired t-test, both variables have to be continuous. So whatever it is you're thinking of as the independent and whatever it is you're thinking of the dependent, both have to be on an interval or ratio scale measurement. And I have a little intervention here. If you're a fan of How I Met Your Mother, you might recognize the intervention they had planned for Robin. But intervention is a good example. If you were interested in doing an educational intervention, say if you thought teachers did not know enough about children with disabilities, and if you were going to educate them on a particular disability, it might make some difference in the way that they viewed those children and their academic abilities. So in this case, you would measure their attitudes towards children with disabilities at time 1, and then you would come back after your intervention, after you provided them something educational, and see, did the attitudes towards the children change in terms of the mean from time 1 to time 2. And here's a basic within subjects design that we've talked about before, but putting it in context. In this case, it's assumed, do children try to smile to just, some kind of like brainstem response that they'll do it for anybody, or is smiling something that is really used at a very young age to try to elicit social interaction? Is it a tool babies use to try to keep mom interacting with them? So, we had the 10-month-old babies, and we were basically measuring smiling under 2 different conditions. The participants are in all of the groups. So with a within subjects design, participants are in all conditions, all levels of the independent variable. So in this case, we had a situation where there are 20 babies, and the mother is paying attention to the babies, interacting with them, and you measure how often those babies are smiling. Then those same exact 20 babies are in the next condition where the mother's just hanging out next to them reading, but not necessarily interacting with them. And the experimenter would measure how often those babies are smiling. So you're comparing the amount of smiling in the first condition with mother's attention to the second condition when mother is reading and not necessarily paying attention to the babies, and seeing is there a difference between those two means at those different times. Now, the paired t-test and the independent t-test both have assumptions of normality of data, that the data is normally distributed, and that they have to have a certain minimum number of participants. Your groups can't be too small. You would have to have maybe at least 10 in a group for a t-test between subjects, and at least 10 participants minimum to sort of run a paired t-test. But what if your groups have very uneven amounts in each condition? What if the data is not normally distributed? What if your sample size is maybe 6 in one condition and maybe 15 in another condition? Obviously, in the first condition, the number is a little bit small. So the paired t-test and the independent t-test are multivariate statistics. They rely on the mean and standard deviation as a sort of underpinning of their formulas. There are non-parametric equivalents to both the paired t-test and the independent t-test that can be used that do not necessarily rely on a normal distribution, and they are good if you end up with particularly small numbers in any one of your groups. So the Wilcoxon matched pair signed rank test is basically an equivalent of the paired t-test. The test, rather than using a mean and standard deviation, transforms each score to a rank score and compares the rank scores. So if you find that you have too small a number maybe for a paired t-test, or if your data is not normally distributed, you might consider the Wilcoxon as a non-parametric equivalent for the paired t-test. The Mann-Whitney U-test is also something that can be used like an independent t-test. Rather than being based on a comparison of means, it's based on the equality of medians. So the statistic that's used as a basis of comparison is looking at the median and whether scores are above or below the median. And this too can be used in the case of small group sizes or a non-normal distribution, and can be a nice substitute for the independent t-test.